Have you ever looked up at the night sky and wondered about the vastness of space? The sheer number of stars, planets, and galaxies is mind-boggling. Each tiny dot of light represents a world of possibilities, a story waiting to be told. The universe is filled with incredible events. From the birth of stars and nebulae to the collision of galaxies, the cosmos is a dynamic and ever-changing place. One of the most amazing is a supernova. This spectacular event marks the end of a star's life cycle, but it also signifies a new beginning. Imagine the biggest explosion you can think of, then multiply that by 1 billion. The energy released in a supernova is almost unimaginable. That's a supernova, the explosive death of a star. When a star exhausts its nuclear fuel, it can no longer support its own weight, leading to a catastrophic collapse and subsequent explosion. Supernovae are incredibly bright and powerful. For a brief moment, they can outshine entire galaxies, making them visible across vast distances. They release as much energy in a few seconds as our sun will in its entire lifetime. This immense energy is not just a spectacle, it has profound implications for the universe. These cosmic fireworks are visible across vast distances. Astronomers can observe supernovae in distant galaxies, providing valuable insights into the life cycles of stars and the expansion of the universe. They are not just destructive events, though. The remnants of a supernova spread essential elements like carbon, oxygen, and iron throughout space. They play a crucial role in the evolution of the universe. These elements are the building blocks of planets, moons, and even life itself. Without supernovae, the universe as we know it would be a very different place. So what exactly is a supernova? It's one of the most spectacular events in the universe, a cosmic fireworks display of unimaginable scale. Simply put, it's a massive explosion that marks the end of a star's life. But there's so much more to it than just an explosion. It's like the grand finale, the last hurrah of a star that has burned brightly for millions or even billions of years. Over its lifetime, a star undergoes various stages from its birth in a nebula to its eventual demise. But this is no ordinary explosion. The energy released in a supernova is so immense that it can briefly outshine an entire galaxy. It's an event of unimaginable power that sends shockwaves across the cosmos. These shockwaves can trigger the formation of new stars and planets, seeding the universe with the building blocks of life. Supernovae are so bright that they can outshine entire galaxies for a short period. This incredible brightness is due to the release of vast amounts of energy and light. Imagine that, a single star brighter than billions of stars combined. It's a mind-boggling thought, but it's a reality in the universe. This intense brightness allows us to observe them from Earth, even when they happen in galaxies far, far away. Astronomers use powerful telescopes to study these distant explosions, gaining insights into the life cycles of stars and the evolution of galaxies. By studying supernovae, scientists can learn about the elements created in these explosions, which are essential for life as we know it. Elements like carbon, oxygen, and iron are forged in the heart of a dying star and spread throughout the universe by the force of the explosion. These elements become part of new stars, planets, and even living organisms. In a way, we are all made of star stuff, born from the remnants of ancient supernovae. The cycle of life and death in the cosmos is a continuous process, with supernovae playing a crucial role in the creation and destruction of celestial bodies. It's a reminder of the dynamic and ever-changing nature of the universe. So the next time you look up at the night sky, remember that some of those twinkling stars may one day end their lives in a brilliant supernova, contributing to the ongoing story of the cosmos. To understand supernovae, we need to talk about stars. Stars are like giant nuclear reactors, constantly fusing hydrogen into helium in their cores. This fusion process releases immense energy, making the stars shine. The balance between the outward pressure from fusion and the inward pull of gravity keeps a star stable. But stars don't live forever. Eventually they run out of fuel in their core. When this happens, the delicate balance is disrupted, gravity takes over, and the star's core collapses in on itself. This collapse triggers the spectacular supernova explosion. Not all supernovae are created equal. There are two main types, Type 1 and Type 2. Type 1 supernovae involve a white dwarf star, the dense remnant of a sun-like star. White dwarfs are like stellar embers, slowly cooling down over billions of years. If a white dwarf is in a binary system with a companion star, it can steal matter from its neighbor. This stolen matter piles up on the white dwarf's surface. If enough matter accumulates, it can trigger a runaway nuclear explosion, resulting in a Type 1 supernova. Section 5, Type 2, Supernovae, the dramatic death of massive stars. Type 2 supernovae involve much larger stars, at least 8 times the mass of our Sun. These stars live fast and die young. They burn through their fuel much faster than their smaller counterparts. As they age, they produce heavier and heavier elements in their cores. Finally, they reach a point where they can no longer sustain nuclear fusion. The core collapses under its own gravity, creating a shockwave that rips the star apart. This is the Type 2 supernova, a truly awe-inspiring event. Section 6, Supernova Remnants, Echoes of a Star's Demise. After the brilliant light of a supernova fades, it leaves behind a remnant, a cloud of expanding gas and dust. These remnants can be visible for thousands of years after the initial explosion. They contain the elements forged in the heart of the star, scattered across space. One of the most famous supernova remnants is the Crab Nebula. This expanding cloud of gas was created by a supernova observed by Chinese astronomers in 1054 AD. Studying supernova remnants helps us understand the processes involved in these powerful explosions. Section 7. The importance of supernovae, cosmic alchemy. Supernovae are not just destructive events, they are essential for the evolution of the universe. The intense heat and pressure within a supernova forge heavy elements like gold, silver, and uranium. These elements are the building blocks of planets, life, and even ourselves. Without supernovae, the universe would be a very different place, devoid of the elements needed for life as we know it. They are the ultimate cosmic recyclers, scattering the ingredients for new stars, planets, and life throughout the cosmos. Section 8. Supernovae and Us, a connection to the cosmos. The next time you look up at a star, remember that it might one day end its life in a spectacular supernova. The atoms in your body were once part of a star that exploded billions of years ago. We are all made of star stuff, connected to the universe through these incredible events. Supernovae remind us of the vastness and wonder of the universe. They ignite our curiosity and inspire us to learn more about the cosmos and our place within it. Section 9. Conclusion. The universe's grand show. Supernovae are among the most powerful and awe-inspiring events in the universe. These colossal explosions occur at the end of a star's life cycle, releasing an immense amount of energy and light. For a brief moment, a single supernova can outshine an entire galaxy, making it visible across vast distances in space. The sheer magnitude of these events is a reminder of the dynamic and ever-changing nature of the cosmos. These stellar explosions mark the end of a star's life, a dramatic finale to a long and stable existence. Stars spend most of their lives fusing hydrogen into helium in their cores, but when the fuel runs out, the core collapses, leading to a supernova. This process is not just an end but also a beginning, as it triggers the creation of new elements and the formation of new celestial bodies. But they also give birth to new elements. The intense heat and pressure during a supernova forge elements heavier than iron, scattering them across the universe. These elements are the building blocks of planets, moons, and even life itself. Without supernovae, the universe would lack the diversity of elements necessary for the complex structures we see today, and shape the galaxies we see today. The shock waves from supernovae can trigger the formation of new stars by compressing nearby gas clouds. This ongoing cycle of star birth and death is a fundamental process in the evolution of galaxies. Over billions of years, these events have sculpted the intricate and beautiful structures we observe in the night sky. As we continue to explore the cosmos, our understanding of these phenomena deepens. Telescopes and space missions provide us with detailed observations, allowing scientists to study supernovae in unprecedented detail. Each discovery adds a piece to the puzzle of how the universe works, revealing the interconnectedness of all cosmic events. We are sure to witness more of these incredible events, each one offering new insights and sparking further questions. The more we learn, the more we realize how much there is still to discover. Supernovae are not just spectacular light shows, they are key to understanding the life cycles of stars and the evolution of the universe. Each one a testament to the beauty and power of the universe. The cosmos is a grand stage where these dramatic events unfold, showcasing the raw energy and creativity of nature. From the smallest particles to the largest galaxies, Everything is interconnected in a cosmic dance that has been ongoing for billions of years. So keep looking up at the night sky and let your imagination wander. The stars above are not just distant points of light, they are the remnants of ancient supernovae and the seeds of future ones. Each twinkle is a story waiting to be told, a chapter in the never-ending saga of the universe, and you might just witness one of these cosmic fireworks yourself. Imagine the thrill of seeing a supernova with your own eyes, a fleeting but unforgettable glimpse into the powerful forces that shape our universe. It's a reminder that we are part of something much larger and more magnificent than we can ever fully comprehend. You never know what wonders await your discovery. The universe is full of surprises, and each new observation brings us closer to understanding the grand tapestry of existence. So keep exploring, keep questioning, and keep marveling at the universe's grand show.